Hello everyone, thanks for tuning in. In this video we're going to talk about clean code. By clean code I mean code that is readable, that is maintainable and extensible. And I think we all know that the hardest part is actually reading code, not the writing part. There are certain expectations when you're writing it, when you're reading it, trying to understand it in order to adapt it. Maybe you want to add a new feature, or you want to completely refactor it to make it more efficient. And I would like to touch on a couple of design patterns and a few practices on this video from the perspective of somebody who is actually reading and refactoring code. Let's go straight to it. Alright, so I'm now here on my VS Code, and as you might have guessed, coming from the title of this file, we're going to talk about naming. And I guess that's often underestimated. Everybody does it, from the most experienced to the least experienced, but there's a certain challenge with naming. So you're trying to encapsulate as much meaning as possible. When you're naming your variables or your functions, for example, you're trying to encapsulate what they're trying to do, what the purpose is, and it's good to think about it as a composite thing. So you can think about it as something that has a core word in the middle, let's say, and you can have a suffix or a prefix where you're basically adding maybe a verb that indicates a certain purpose. And this is something we're going to look into right now. So we have a very simple snippet. It's actually an asynchronous function. Inside there's a try catch, and this is basically fetching data from an endpoint, right? So the name of the function is get. That's good so far. We're getting something. We're fetching from this endpoint items available, right? So if the response is not okay, we're gonna throw an error. Otherwise, we just await and call the JSON method on it. This basically returns the data as a JSON. If there's an error, we're going to catch it, and we're going to console log a string with the error, and we're going to return an empty list. So I think we can rename this to better reflect what it's doing. And how I like to do this is, I think get is a good first. It's a good prefix because we're fetching from an endpoint. But what are we returning? And this is actually revealed by the path names here, items, and available. So for example, you can say get items, which is completely fine. It's already reflecting the information we're getting, the data we're getting. But we can take it a step further and say get available items. And just by looking at it, before you get into the code inside this function, you can get an idea, okay, you can get an initial impression, I'm getting available items. So depending on the context of the rest of the code base, you understand what this is about. Okay, so the next thing we're going to talk about is the guard clause. Now, you'll see what I mean in practice. Let's look at this function. From the name of it, you can already assume that it's returning a Boolean value, is form valid. It's going to be either true or false. And we're taking in data. Now, the first thing we're checking is whether the email is valid. And that's a method somewhere in the code base. If this condition is met, we're going to check for the other properties we would like to validate. In this case, it's message and its length. And if those conditions are met, then we're returning true. Otherwise, we're returning false. Now, this code is good today. Perhaps tomorrow you're adding more properties, the form becomes more complex, and you're forced to nest more if-else statements. And this can get awkward quite easy. Therefore, a better practice would be to attempt an exit early. What do I mean by that? Let's reverse those conditions. Let's say if not is email valid, and in this case we're going to return false. Let's clean up the bracket here. Let's take this, let's take this one step back, clean up the bracket. And we're going to say if not data has on property message, and let's turn this into or the data message length is equal to 1, then we'll return false. And when we're at this point, I mean, if those conditions are not met, then of course we can return true because the form is valid. Now, as you can see, if you're adding more conditions, then it becomes more readable. And especially for somebody who doesn't know what you're doing, they can easily understand, okay, you're just validating a few conditions. Oh, I want to add my own. I can do that easily. And I think that's the real benefit of the guard clause. Okay, the next thing we will attempt to beautify are the loops. And I think this is quite straightforward. What this code is doing is basically iterating over items. If the single item count is greater than 0, then we're pushing the item name to the array we have defined here. Now we can achieve the same result leveraging this pattern called collection or pipelining. We're going to comment out the code here. And what we're going to do is we're going to define available items, and we're going to take the items, which is already an array, and we're going to call a method on the items. This is basically for filtering. So in here we're going to say item, and if item count greater than 0. Now the results we can map, and in a similar fashion, item name. So this is exactly the same as the code that is commented above. I think it's much more elegant, much more readable, because it clarifies already from the beginning, okay, this is what I'm getting. I'm using filter, and I'm using map to get the new array of available items. Finally, we're going to talk about the null object pattern. And this is something that you do in your code base. One way or another, you're checking whether an object is null before accessing any of its properties or methods. This is fine, but it can become quite tedious. So an alternative to that would be that you define a default item, right? Kind of like a placeholder for null. You can say, okay, I have this item, I define it with those properties. This will be the default in case what I'm expecting comes out as null. So what do I mean by that? Let's look at this function, item description. So this one takes in an item, checks whether it's null. If it is null, if it isn't null, it returns this string with color and weight. Otherwise, it returns another string that says the description is not available. I'm going to refactor the code, but I'm also going to change it slightly just to match what the point I'm trying to make here. So let's imagine there is a default item. We're going to define it as, let's say, null item, and this null item has the property color. We can say that it's unknown, but it also has the property weight. Let's say it's 0. Right. So here in the parameters section of the function, we can say item is initially null item. This means null item is the default. In case the parameter passed is null, then it actually is the null item. And you do not need to check for null anymore. So we can remove this. And we can directly return the color and weight string that we had before. And you're basically defining the same shape that you're expecting in the item parameter. So I think this is a much more readable approach to always checking for null and then coming up with an alternative value or an alternative return statement. And with that, we conclude this video. I hope it incited your curiosity to look into those patterns and practices even further. Remember that readable code is not a binary state, and it also depends on your programming language and your team. So be open for discussion. If you enjoyed the video, make sure to check out my blog post on thoughts on how to write cleaner code. The link is in the description of the video. Thanks for tuning in, and seeing you on the next one.